This is the first video on chapter 47, parametric equations and surface area. And so in this video we're going to look at example 268. The parametric equations that were given, x equals t squared plus 1 and y is 6t. And we're going to look at the curve from t equals square root of 7 to square root of 55. And so we're just going to apply the surface area formula. So we calculate the derivative of x with respect to t, we calculate the derivative of y with respect to t. This is the expression we're going to integrate. So we look at 2 pi y, derivative of x squared plus the derivative of y squared, that sum under the square root. We'll substitute right here, y is 6t, x prime is 2t, y prime is 6. We simplify this by factoring out a 4, so square root of 4 is 2. So this expression simplifies right here, and then we integrate from square root of 7 to square root of 55. T squared plus 9 under the square root can be written as a quantity t squared plus 9 to the 1/2 power. So when we find an antiderivative, our expression has a t squared plus 9 to the 3/2 power. And then we have to multiply by the appropriate constant. So take the derivative here to check your answer. So we have 3/2 times 8 is 12. So we have 12 pi. The quantity t squared plus 9 to the 1/2 power, then we multiply by 2t. So our 12 pi times 2t is our 24 pi t. So this is the antiderivative. We'll substitute square root of 55 for t. We'll substitute square root of 7 for t, then we subtract. When we substitute square root of 55 for t, we have 512. When we substitute square root of 7 for t, we have 64.